Good afternoon. This semester, I'll be teaching Mathematical Foundations of Information Technology. So in this lecture, I'll be going through with the introduction, course objectives, course outcomes, and the syllabus. I'll just give a brief introduction and then we will see the syllabus. Let's begin. Introduction. Why do we need a separate mathematical course for the students of information technology? Generally, whenever we think of mathematics, we think of students taking a question, and for that question, you give off a solution. Okay. So for us, for the mathematical students, the important part is solutions. Correct. Always, everyone till now has focused on the solutions for a given problem. Right. So mathematics is basically at the heart of problem solving. Defining a problem requires mathematical accuracy or precision. So to define a problem, we require mathematical accuracy, correct? And for this, in computer science or information technology, whenever you are using mathematics, it is required in data structures, models. So over here, when we think of mathematics, we think of data structures, algorithms, and those make the foundation of mathematics. And by now, if you have got the point that in computer science, we don't just program or we don't just perform software engineering. We are supposed to do a bit of problem solving. So the important thing required is problem solving. So over here, for problem solving, first we require to give a problem. Okay, first we require a problem. The customers or the representatives, they just define a problem. They just give you a abstract of what they require. And then you have to define a problem and you have to give a solution. Now, suppose if in a company you have 4 or 5 engineers working, I'm considering 4 engineers who are working together on the same problem. Now, each of them will give 4 different solutions. We get 4 different solutions from each of the engineer. Now, how should an engineer justify why his problem should be chosen? So engineer 2, I suppose, is telling that my solution should be considered. How can one define that? So that efficiency and whether the solution is correct or not requires an analysis which can be defined by some kind of mathematical model. So mathematical model is required. Now, this is an example that I've taken so that you understand what kind of problems we can solve using MFIT. Consider a cab company which has hired an engineer, and suppose that engineer is you, and you are supposed to write a computer program. You are supposed to write a program to automate their cab company. Okay, so to automate their cab company, you are supposed to write a program. And in this scenario, businesses, or here instead of businesses, we can also consider customers. Okay, instead of businesses, we consider customers. Customers are requesting a cab along with a driver. So over here, customers are requesting a cab along with a driver. This is your normal cab company. You can take one of the examples of either Uber or Ola. Okay, and customers are requesting cabs and drivers. Now, the scenario is that for a fixed period of time, they book their cab. So they specify the start date. So suppose if I take the example, we have a cab from 7 a.m. A customer is booking a cab from 7 a.m. to 7 p.m. Okay, and they are charging some rate, so kilometers, rupees per kilometers maybe. So rupees per kilometer, they are charging a rate. Now our issue is that what we are supposed to do is we are supposed to give the maximum number of customers to the company. Okay, so this is the outcome that is required, or the result. Okay, so this is the outcome that is required, that maximum number of customers should book the cab from the cab company. Okay, now apart from the maximum number of customers, there is one more thing which companies or businesses look for. So if you can guess that, it is profit. Okay, so apart from the maximum number of customers, they also require the maximum total profit. So over here, we also require maximum total profit. Okay, so in the second scenario, that is your second task, is to design the program in such a way that the cab service. So suppose if you're hiring an auto over here, if let me take an example of auto. If you're hiring an auto, the customer gives their rate and the driver decides whether it is feasible for him or not. Similarly, over here, the cab services are allowing to bid on a ride. Okay, and it is in such a way that whoever has the highest price for the cab. So if the customer has the highest price for the cab, the customer can book it. Okay, so this will result in this total profit being maximum. So total profit is maximum. And also another condition that you have already studied is maximum customers. Okay, now one more important thing to be considered is no cab should be assigned two or more customers at the same time. So if there is one cab, it should be assigned one customer. Okay, so if there is one cab, only one customer should be assigned. Now, how will you decide on the algorithm or the program? So for now, that is not important, but we will look at what are the different points to be considered while designing our algorithm. So for each problem, we will build a mathematical model. Okay, we will build some kind of mathematical model over here for each scenario. And for each scenario, we will develop an algorithm. Okay, so we will check for the number of customers. We will design a formula for getting the cabs. Each person should be assigned only one cab, etc. Now, for our solution to work, it should satisfy few conditions which are given over here. So if you remember, you have already studied the algorithms. What are the conditions that an algorithm should satisfy? So first and foremost, our algorithm should be finite. Okay, it should be finite. That is, it should terminate or end. Okay, so our algorithms should always end somewhere. Then the next thing is, every time you're writing an algorithm, the important criteria is it should complete. All right, so complete algorithm which gives at least one solution, we require that. So first is the algorithm should end. The second thing is it should complete. Now suppose if we get a solution, we have to check whether the solution is correct. Okay, so that thing is known as soundness. Okay, now if our solution is correct, there may be two or three solutions, or there may be more than one solution for the algorithm. Now next thing to be considered over here is optimality of the solution. Optimality means we have to find the best solution. The next thing is we have to check that the algorithm ends at some amount of time and takes some space that is required. After that, now coming to what is MFIT. Till now, whatever we have studied is why we require the mathematics. Now, the next thing is, why do we require MFIT? MFIT is basically something known as discrete mathematics. It is a different term for discrete mathematics. Discrete mathematics is a collection of topics that examine and use finite mathematical objects. So discrete mathematics is a collection of mathematical topics. So different topics that are included in MFIT are sets, relations, permutation and combination, etc. The common name for MFIT that is usually used is discrete mathematics. Discrete mathematics is the backbone of computer science and information technology. Concepts and notations from discrete mathematics are useful in studying and describing objects, and this subject is used in various branches of computer science such as algorithms and cryptography, parallel computing, etc. Most of the further branches that you will study in the next semesters use some of the concepts of discrete mathematics. Also, now whenever I mention the term discrete mathematics, it can be used synonymously with MFIT. And modern computer science, which is used, it is built on these foundations, especially the topics of permutation and combinations, graph theory, which is another important subject. Graph theory, they are based on discrete mathematics. Now, every time I mention the term discrete mathematics, once again, let me say it is a synonym of MFIT. Let me define discrete mathematics. It is the study of discrete objects. Now, what do you mean by discrete objects? Discrete objects is basically distinct objects or unconnected elements. So distinct or unconnected elements. What are the kinds of problems that you can solve using discrete mathematics? So these are a few examples that I have mentioned over here. So how many valid passwords? So the first example uses the concept of permutation and combination. And the second example is the concept of probability, right? Probability of winning a lottery. Similarly, spamming of email messages, that is based on keywords. Encryption of messages, encryption and decryption. Shortest path, which is a problem of graphs. So these are the various problems that we will study in the further lectures. And this is just an example so that you understand the basics. Now, the next thing that we have to look into is the course objectives. Course objectives for this subject are, we have to understand the basic terminology of functions, relation, and sets. So the first chapter includes these topics: functions, relations, and sets. All the three topics have been studied earlier, and they just make us understand that functions, relation, and sets that can be used in computer sciences. And to perform the operations associated with functions, relations, and sets, and the first three objectives are similar and are associated with sets, functions, and relations. The next thing is importance and limitations of predicate logic. Now, predicate logic is something that deals with the logical aspect of information technology. So whenever we tell logic, it is something that is used in circuits, the computer circuits, and solving mathematical problems with logic, etc. Now, after that, we also study mathematical induction. Mathematical induction is also a topic that has been studied earlier. So we will understand the real-time application of mathematical induction. And then the last thing is graph theory. So mathematical induction and graph theory are the two topics which mathematical induction is something that you have studied. The graph theory topic will be different. Next, course outcomes. So at the end of this course, what are the things that you will learn? So as I have said earlier, you will study functions, relations, and sets, and then understand the basics of counting, permutation, and combination, which is an important part of MFIT. The next thing is recursion. So already in C programming, you have studied something known as recursive functions. So a part of recursive function is recurrence relation and recursively defined relationships. So we'll study a bit of that. Then we have uh, computer group theory applications. This will be a new topic and we'll study it soon. And then again, permutations, combinations, and graph theory that I've already explained in the last slide. So permutation and combinations are something that you have already studied. Then we have graph theory. Next. Now, what constitutes the syllabus of MFIT? So first and foremost, we have mathematical logic. So mathematical logic deals with two things, which are propositional logic and predicate logic. So propositional logic, and the second thing is predicate logic. This will be the next lecture on the subject, propositional and predicate logic. Along with that, the different operations that can be done on propositional and predicate logic, and a bit of group theory. So why do we need logic and proofs? For this, we have to understand how do computers think. And the areas in which propositional and predicate logic are used are artificial intelligence, the last line of this slide, artificial intelligence, database circuit, algorithms, etc. So these are the areas where logic and proofs are used. Next chapter includes the topics of relations. So relations is something which is a part of sets. So once we complete sets in unit 1, we will start with relations. In relations, we will study the different properties and algebraic systems. All of these will be covered. Then the next thing that will be studied is combinations, permutation and combinations, inclusion exclusion theorem. So if you remember, these were the things that you have already studied: NCR, NPR, and a plus b whole power n formula, all of these things. So these topics will be covered in unit 3. And where do we use this? If you remember, even while we were doing permutations and combinations, you have various kind of problems based on the selection of ball, a pack of cards, etc. So in these problems, we will study, and the usage of permutation and combinations is done in probability, algorithms, and data structures. And these are the few subtopics for counting problems. Next is number theory. Number theory is for cryptography, coding theory, data sequence. I am in these slides, the slides which are just given here, I am giving you the subtopics of your syllabus. These are the subtopics, and the last line of the slides are the applications. So cryptography, coding theory, data structures are the applications. Then the next thing we have is recurrence relations. As I've already mentioned, recurrence relations are basically very similar to recursive functions. So we recursively take a relation where we use it recursively to find the next terms, and based on all those topics we have generating function sequences. So this can be similar to arithmetic geometric progressions because those were also sequences. So you can take that as an example, and anyway we'll be studying it in the later classes. Then the next topic we have is graph theory. Graph theory is basically when graphs in computer science are not those that you use in mathematics. So in graphs we have two vertices, one or more vertices, and whenever we connect the vertices with a link, this is known as an edge. So graphs in computer science are basically a combination of edges and vertices. So those are denoted by G is equal to V comma E. We'll study it further, but just for introduction. So you should not think of it as the graph papers that you used in mathematics. Here they are a bit different. So in graph theory, a very important topic with respect to the subjects that you will study further in the later semesters, and all the topics of graph theory are also included in another subject that you're studying right now, which is data structures. The next thing here, if you see, so graph theory, it is the main application of graph theory is computer networks. The last line, if you look at the last line, so here we have computer networks, circuit design, data structures, etc. Now, for graphs, if you look at the example which is given, the second example, which is you have a network of computers. Yeah, you have a network of computers. So this is the first computer. You have a few computers over here. Okay, I'm naming those as 1, 2, 3, 4, 5. Then those are connected by the edges. And this basically constitutes what is known as a graph. We'll anyway study it further. This is just a basic introduction. And the main applications are underlined: computer networks, circuit design, and data structures. And the suggested readings for this subject have been given. And the ones underlined, the first three textbooks, are the ones which are important and should be referred. The next three can be taken for educational purposes, but the first three are the ones which has the syllabus. Now let's recap. What did we learn? So we first learned why do we need MFIT. Next is what is MFIT. Then your course objectives. Then you have course outcomes. And the last thing that we studied was this syllabus. Thank you. We will look at unit 1 in the next class.